Thank you for coming. Can everyone hear me all right? I'm here today to present on a meta-analysis used to examine what habitats and disturbance variables influence songbirds in the boreal forest of northern Alberta. And I'm looking at what scale of influence. And so I have a question. Who likes black flies? Well, a few of you, but not too many. So one very good reason to like birds, songbirds, is that they eat bugs. And I was looking at how many species are in the boreal, how many individual birds. It looks like they could be eating up to 1 trillion insects in the summer. So if you think the bugs are bad in the summer, think how they'd be without these songbirds eating them by the trillions. Canada's boreal forest is critically important breeding ground for 3 billion North American songbirds. Over 300 species regularly breed in Canada's boreal forest. This is about half of the songbird species that regularly occur in Canada and the US. Boreal songbird species range from common species you might be familiar with, like the American robin, or more rare species like a black and white warbler at the far left, or the yellow-rumped warbler. Over 60% of North American breeding birds are neotropical migrants, meaning that they're up in the boreal in the north to breed in summer, and in winter they head to a tropical vacation destination like Mexico or Brazil. So Canada and US have an agreement under the Migratory Songbirds Convention Act to protect habitat necessary for the conservation of migratory songbirds. In Canada, there's additional federal and provincial legislation that also protects songbirds that might be declining in Canada. We focused on a guild of mature forest songbirds. So here, mature forest, we considered had trees 60 years or older, and usually that type of forest would have some component of white spruce, could be deciduous, or mixed wood also. This was a group of 27 species. 10 of them are listed as species of concern, and 19 are neotropical migrants. Our study area is the large bay shape up in the northeast and is in the oil sands region, which is an economically important source of oil, as we all know. We have data from over 2,000 point counts in this area. A point count is what we call bird survey. And with all the human development we're hearing about a lot of it today, this area's already got expansive linear and non-linear disturbance. With this, and it's from forestry, oil and gas, urban development, with this habitat loss and fragmentation, there are concerns that wildlife species numbers may be declining. Our ultimate goal is to improve environmental impact assessments. We want to predict where songbirds are in the landscape and the potential impacts of future disturbance on boreal songbird. Our first objective was to confirm general habitat associations of boreal songbirds in the oil sands region. Second, we wanted to identify what habitat and disturbance variables had the greatest influence on songbird relative abundance. Relative abundance in this case is referring to the number of individual birds that we counted in a point count survey. And third, we wanted to examine different zones of influence in ZY surrounding the point count to better delineate the scale or scales at which various disturbant types and habitats affect songbirds. And I'll explain more about how I'm defining a zone of influence shortly. Songbird data were collected in 100-meter radius point counts. We restricted data to 50 meters to have a homogeneous habitat at the point where we were observing birds. Among other items, the observer recorded the species and number of individuals, mature forest songbirds that were observed. And with this local scale at the point count, we used digitized vegetation maps compiled from Alberta Vegetation Inventory, AVI, field data, and photo imagery to create local variables to control for the local habitat influence. So at this local scale, we were looking at the habitat type in which the point count was found, and that was out of 15 possible habitat groups. We looked at height of the tallest tree layer or vegetation layer, whether it was a 2-meter tall shrub or a 30-meter tall aspen tree. And we looked at percent canopy cover of 3 kinds of old growth trees, so those would be trees older than 80 years. Jackpine trees, deciduous trees, and other upland conifer. We used 3 scales to evaluate the zone of influence of the surrounding landscape on the relative abundance of songbirds observed at the local 50-meter point count. So here I'm not really talking about a zone of avoidance. I'm talking about if you look at a zone around the point where we observed birds, at what scale are we still seeing effects on songbirds at the point, which is where we're collecting the data on birds. We looked at 3 scales. The first was 250-meter radius zone, then a 500-meter radius zone, and a 1,000-meter radius zone. And in these zones, we calculated the proportion of the zone that were different disturbance or habitat types. The type of disturbance is likely to have a strong influence on songbirds' response. So we used a proportion of the circular zone. There were 3 disturbance types as variables. So these were non-vegetated linear disturbance, like a road, vegetated linear disturbance, like a shrubby cut line, and non-linear disturbance, like a cut block or well pad. We also looked at a summed overall disturbance variable. We were trying to tease apart if the disturbance type was important. We also were controlling for the surrounding amount of habitat preferred by boreal songbirds in these zones. So we looked at how much mixedwood aspen-white spruce, coniferous white spruce, and deciduous aspen, balsam poplar was making up these zones. We expected these to attract birds because they have, well, just think of trying to attract birds to your backyard. If you have a lot of shrubs and tall trees, places for the birds to forage and hide, build nests, you'll get them in there. So things that help them find their bugs that they eat, and tall shrubs like cranberry. We also looked at non-preferred habitats, which tend to be more open, dry, not a lot of foraging or nesting opportunities. So we used statistical regression models to understand how mature forest songbirds are related to the variables we were interested in. We compared models that contained different sets of variables to determine which variables best explained songbird relative abundance. First, we confirmed the expected patterns of habitat associations. Here we have mean relative abundance of mature forest songbirds per point count over habitat group on the x-axis. Very simply, the mature forest songbirds preferred the mature forest, with a trend for highest relative abundance in the mixed with aspen white spruce, coniferous white spruce, and deciduous aspen, balsam poplar habitat groups. Relative abundance was lowest in the very wet, non-treed open wetland, and also in the dry jackpine black spruce habitats. As you can see from the standard deviations, there weren't many statistically significant differences, but we did confirm our predictions about which habitats would be important. So when we went through and compared our models, we had 2 top models that retained the 1,000-meter zone of influence variables. A key difference between them was that one model had used the summed disturbance variable in the zone, and the other retained the variables that were the 3 different detailed disturbance types. And I'll get into a few highlights of the top models in the next few slides. When we compared our models, we found that models with the local habitat group variable have substantially more support than models without it. So the local condition where the mature forest songbirds were observed matters a great deal, as these birds are seeking out their suitable nesting and foraging habitats. There's also substantial evidence for the zone proportions of the 3 habitat types that were preferred habitats for these songbirds. And these detailed preferred habitats had more support than non-preferred habitats. However, zone of influence models with disturbance variables tended to have a greater explanatory power than variables that just had, or models that only had natural variables. So the three preferred habitat types did have positive coefficients. At the local point count scale, they were positively associated with these habitat types, and the amounts surrounding them in the zones had the same positive influence. Mixedwood, aspen-white, spruce seemed especially important in the zone of influence, so we tested its interaction with local habitat. The 1,000-meter zone of influence amount of mixedwood, aspen-white, spruce has a negative influence on relative abundance of mature forest songbirds when local point count habitat is a suitable habitat type. So this was significant when the local habitat was coniferous white spruce. Possibly this shows that songbirds prefer mixedwood, aspen-white, spruce above all else. Northern migrant bird populations are normally limited by territoriality, meaning that they prefer to have their own space, and if the surrounding 1,000-meter zone has a lot of the habitat that they would like, they're going to space out, and they'll set up their territories further apart in the available habitat. I'm not sure if I said that backwards. So anyway, when you have more mixedwood, aspen-white, spruce around the point, there appears to be a negative influence because they will move out into that mixedwood, aspen, is what we think is going on. There's a positive influence of the surrounding mixedwood, aspen-white, spruce when the local habitat is a non-preferred habitat type. This is significant for non-treed open wetland and treed bog. What we think might be happening here is that the birds are spilling over from their preferred habitat into a non-preferred habitat. So the more you get surrounding the point where we observe the birds, the more likely it is that a bird might sort of briefly be out in the open habitat long enough to be surveyed and then back into their preferred habitat. It could also be that our mature forest guild includes two edge-associated species. They are forest species, but they like edge, so if you get more of their preferred forest around an open edge, we could be seeing this effect. When we look at the local variables at the point, models with height have more support than models with the percent cover of old growth trees. We think this could be due to the fact that the height might be a simpler measure of a similar concept, in that these birds are selecting areas with tall trees, old trees. When we look at the percent canopy cover of old jackpine, there is a negative influence on relative abundance of birds. So this is what we expect. It's an open, low diversity, dry area that we would expect to have this negative influence on birds. As height increases, the relative abundance of mature forest songbirds increases, and mainly this seemed to be a transition from a vertical structure of grasses and shrubs in a wetland to taller shrubs in a bog or a swamp, and then finally the tall trees in their preferred upland habitat. When we are comparing now the local models to accounting for the larger landscape influence, we found that local variables alone perform slightly better than the zone of influence variables alone would. However, if you combine that local habitat influence with the surrounding zone proportions, you get the top models. And if you're looking only at the zone of influence models, evidence supports the 1,000-meter zone as being best, and the smaller zone, 250 meters, is a close second. So this is telling us that both the fine scale point count variables matter, and the large scale influences are important. Contrary to predictions, the type of disturbance was slightly less important than just an overall disturbance variable. That said, detailed disturbance, having the three types, still performed better than having no disturbance variables in the model. When we looked at vegetated linear disturbance, there was a negative influence on the relative abundance of mature forest songbirds. So as you get more shrubby cut lines, you get less birds at the point. We thought this could be due to habitat degradation. So as the habitat at the point becomes increasingly degraded, songbirds might have to perhaps enlarge their territories and can't be in as close together and still get the resources that they need. Because this disturbance type is vegetated, the birds might also be able to cross into a new area of territory. They won't be trapped at the point. There is a positive influence on mature forest songbird counts with non-vegetated linear disturbance, non-linear disturbance, and the overall all disturbance. So as you get an increase in most of types of disturbance, we saw an increase in the birds at the point. So this was a little trickier to understand. A possible explanation is that as disturbance increases, songbirds are seeking the last remnant patches of habitat. Just as we were out there observing the birds, we were looking for a patch of forest that was far enough away from disturbance that we could say, okay, these are where the forest birds are. Well, the birds need a patch of forest to live in. So we could be getting this increase there just because there's nowhere else for them to go. If this area is actually getting overcrowded, it could be acting like an ecological sink, such that birds are moving in there, but not being able to breed successfully, or not being able to get enough resources, and dying off, and it's like going down the drain in this remnant patch. So demographic studies looking at breeding success, survivorship, dispersal would be needed to determine what exactly is causing this. So in conclusion, we did find that mature forest songbirds selected habitats with moist soils, large trees, really shrubby understory. Vegetation cover is high in these types, and they provide a wide variety of foraging and nesting microhabitats. Local variables were important predictors of mature forest songbird relative abundance, so they're both negative and positive associations. And we found that the 250-meter zone had an important influence also, which supports having some of that fine scale influence. But we also found that the landscape context is quite influential. So the highest zone that we looked at was up to 1 kilometer from the point, and we were still finding variables from this 1,000-meter zone included in our models. So this tells us that we can't just look at what's at the point, it's what's around it that matters. And the direction, when we look at disturbance types, whether it's positive or influence can vary with disturbance type. With management implications here are that if we continue to do impact assessment focusing only on the local scale, we could be misleading ourselves. A common practice is to look at where were the birds found locally, which habitat types were they in, and then from there try to predict how the development will affect them. But what we found is that consideration of the cumulative effects of the surrounding zones of disturbance natural habitat types is required if we are to accurately predict development impacts on boreal songbirds. So I'd like to thank everyone who contributed to this meta-analysis, and thank you to Alberta Upstream Petroleum Research Fund and Petroleum Technology Alliance Canada, the forum organizers, and thank you to everyone who came.